One of the big news items recently was the discovery of a planet that may end up being the closest planet to us in our own solar system, Proxima b. The James Webb Telescope has finally revealed the clearest ever image of Proxima b, our closest Earth-like neighbor just 4.2 light-years away. This mysterious world, which orbits its star in just 11 days, might actually have water in its atmosphere. Could aliens be living right next door? The image is breaking the internet as experts scramble to figure out what those unusual patterns on the surface might be. Is this the discovery we've all been waiting for? NASA won't confirm anything yet, but space fans are going wild with theories. The historic first clear view. After years of waiting, the James Webb Space Telescope finally dropped the most incredible image of Proxima b ever captured. This isn't just any space photo. This is history being made right before our eyes. For the first time ever, we can actually see details on this mysterious world that's just 4.2 light-years away from Earth. Before now, Proxima b was just a concept, just data points on a screen that scientists detected through tiny wobble in its star. But now, we've got an actual image that shows colors, features, and patterns that nobody expected to find. What makes this even more amazing is that nobody thought we'd get such a clear picture this soon. Most experts thought we'd need to wait for the next generation of space telescopes before we could see any exoplanet in this kind of detail. But the Webb team developed this crazy new imaging technique that basically lets them subtract the star's light in a way nobody had tried before. It's like they found a way to dim the headlights of a car to see the firefly sitting on the hood. The image is so detailed that you can actually make out major features on the planet's surface. We're talking about seeing things that are only a few hundred kilometers across on a planet that's trillions of kilometers away. It's like being able to see a penny from thousands of miles away. The clarity has stunned even the scientists who designed the telescope. One NASA researcher actually cried when the first clear image came through, saying, "This single picture answers questions we've been asking for decades, and the timing couldn't be more perfect." Just as private space companies are ramping up their technologies and talking about interstellar probes, we get this incredible glimpse of what might be the first planet humans could potentially visit beyond our solar system. This image doesn't just show us another world. It gives us a destination, a goal, something concrete to dream about when we look up at the night sky and see that faint red dot where Proxima Centauri shines. Surprising surface features. The internet literally exploded when people saw what's actually on Proxima b. The image shows these crazy blue-green patches that nobody predicted would be there. Scientists are freaking out because these patterns look suspiciously like they could be oceans or some kind of liquid on the surface. The most stunning part is this massive band of greenish-blue that wraps around what seems to be the planet's equator. It has these swirling patterns that change shape over time. They took multiple images over several days, suggesting some kind of dynamic system. Maybe ocean currents, maybe atmospheric patterns, maybe something we don't even have a name for yet. Some of the researchers are saying it reminds them of how Earth's oceans and weather systems appear from space, which is blowing everyone's minds. There's this one region near what might be the North Pole that shows this super bright reflective area, possibly an ice cap or some other highly reflective material. It's surrounded by these dark spiderweb-like lines that radiate outward, almost like cracks in ice or river systems flowing from a glacier. Nobody expected to see this level of complex surface detail, especially not patterns that seem so familiar yet so alien at the same time. And check this out. There's this one dark spot near the equator that's perfectly circular, about the size of Australia. It doesn't move or change like the weather patterns do, and it absorbs almost all light that hits it. Some scientists are suggesting it could be an impact crater, while others think it might be some kind of massive geological feature like a supervolcano. A few fringe researchers are even suggesting more exotic explanations, but most serious scientists are staying cautious until we get more data. Either way, this unexpected feature has everyone scrambling to update their models of how Proxima b formed and evolved over billions of years. The daylight mystery. One of the coolest things about this new image is how it reveals both the day and night sides of Proxima b. Most scientists thought the planet would be tidally locked to its star, meaning one side would always face the star in permanent daylight while the other remained in eternal darkness. Kind of like our moon always shows the same face to Earth. But the image shows something way more complex. There appears to be this weird twilight zone between the day and night sides, suggesting the planet might have an atmosphere that distributes heat. What's really wild is that the terminator line, that boundary between day and night, isn't a straight line like you'd expect on a tidally locked planet. It's this wavy, irregular boundary that shifts position slightly in different images taken over time. This suggests Proxima b might have a weird orbit or rotation that nobody predicted. Maybe it's in some kind of resonance where it rotates 3 times for every 2 orbits. Or maybe it has a wobbly axis like a spinning top that's about to fall over. Whatever the explanation, it completely changes our understanding of how planets around red dwarf stars behave. The day side itself is another mystery. Instead of being uniformly bright like scientists expected, it has these dark patches that absorb more heat than the surrounding areas. One theory is that these might be deep ocean regions that act as heat sinks, absorbing energy during the day and potentially releasing it at night through some kind of global circulation pattern. If true, this could create microclimates across the planet where temperatures remain moderate enough for liquid water to exist permanently, not just in certain regions. And those lights on the night side, they're not random. They seem to cluster in specific regions, particularly around the edges of what might be continents or along what could be coastlines. Some appear and disappear over time in the different images, while others remain constant. The consistent ones could be geological features like volcanoes, while the transient lights might be massive storm systems with lightning many times more powerful than anything we see on Earth. The pattern is too regular to be random, but too chaotic to immediately suggest artificial origin. It's one of those mysteries that has scientists developing dozens of competing theories, each more fascinating than the last. Signs of atmosphere. This is huge because most scientists worried that the intense radiation from Proxima Centauri would have stripped away any atmosphere long ago. But the James Webb Telescope's infrared instruments picked up these amazing heat patterns and light absorption signatures that strongly suggest there's a substantial atmosphere surrounding the planet. The image shows what looks like cloud formations and even possible weather systems swirling across the surface. The atmosphere appears to be creating this soft blurred edge around the planet instead of a sharp boundary between space and surface. If confirmed, this discovery completely changes our understanding of how planets around red dwarf stars evolve. The presence of an atmosphere could shield the surface from harmful radiation and potentially allow for liquid water to exist, which is the key ingredient for life as we know it. Researchers are already analyzing the spectral data to determine the atmospheric composition, looking for water vapor, carbon dioxide, methane, and other gases that could indicate habitability or even biological activity. The spectral analysis is where things get really interesting. Early data shows absorption lines consistent with oxygen, water vapor, and get this, methane. On Earth, methane in the atmosphere is primarily produced by living organisms. So, finding it on Proxima b has some scientists cautiously suggesting it could be a potential biosignature. Others are more conservative, pointing out that geological processes can also produce methane under certain conditions. Either way, the chemical cocktail detected so far suggests a dynamic atmosphere that's not in chemical equilibrium. Another possible sign of either active geology or even biology. The atmosphere also seems to be doing something really important, protecting the planet. The images taken during a small flare from Proxima Centauri show what appears to be auroras in the planet's upper atmosphere. Much like our northern lights, but spanning much larger regions. This suggests Proxima b might have a magnetic field that working together with its atmosphere shields the surface from the worst of its star's radiation. Without this protection, any liquid water would likely be stripped away and any potential life forms would be bombarded with lethal radiation. The fact that we're seeing signs of both an atmosphere and possibly a magnetic field means Proxima b might be much more hospitable than anyone dared hope just a few years ago. Water possibilities. There are these massive blue regions that reflect light in exactly the way water would, and they seem to have coastlines where they meet what could be continents. Scientists are being careful not to jump to conclusions, but many are privately admitting they're shocked by how Earth-like these features appear. The infrared data suggests these regions have different thermal properties than the land areas consistent with large bodies of liquid. If these really are oceans, it completely transforms our understanding of this planet's potential to host life. Water is the universal solvent where life as we know it developed. So finding oceans on our nearest neighboring planet would be mind-blowing. The image also shows what might be ice caps at what would be the poles of the planet, suggesting a complex water cycle similar to Earth's. Researchers are already debating whether these oceans would be water or some other liquid given the different conditions on Proxima b. But the evidence is mounting that some kind of liquid exists on the surface. The spectral analysis of these regions shows absorption patterns consistent with water in liquid form, but with some weird differences that have scientists puzzled. The light reflecting off these surfaces has some unexpected wavelength absorptions that might indicate the water contains dissolved minerals or other compounds in much higher concentrations than Earth's oceans. Some researchers suggest these might be more like salt lakes or even bodies of liquid with completely different chemistry than what we're familiar with. One wild theory is that they might be methane or ammonia lakes rather than water, though the thermal properties seem more consistent with H2O. If confirmed, this would be incredible evidence that Proxima b has active Earth-like systems that could potentially support some form of life. The presence of a dynamic water cycle also suggests the planet has been stable for a very long time. Long enough for complex systems to develop and reach equilibrium, possibly even long enough for life to emerge and evolve. The size revelation. The new image has settled a huge debate about Proxima b's actual size. For years, scientists could only estimate its dimensions based on indirect measurements. Some thought it was much bigger than Earth, while others suggested it was slightly smaller. Well, now we can actually see it. And it turns out Proxima b is about 1.3 times Earth's diameter, bigger than our home, but not by much. This confirms it's a rocky world rather than a gas giant, which is super important for habitability. The image reveals the planet's distinctive spherical shape and even shows some flattening at the poles, suggesting the planet rotates on its axis. This rotation is crucial for creating daylight cycles and potentially distributing heat around the planet. The clearer understanding of Proxima b's size helped scientists refine their models about its mass and density, which in turn tells us about its internal composition. The size confirmation is especially important because it helps us understand the planet's gravity. With a diameter 1.3 times Earth's and a mass about 1.27 times greater, Proxima b would have a surface gravity around 1.15 times what we experience on Earth. Strong enough to hold an atmosphere, but not so strong that it would be crushing to theoretical human explorers or to any life forms that might have evolved there. This Goldilocks gravity is another tick in the potentially habitable column for our nearest exoplanet neighbor. The size measurements also reveal something unexpected about Proxima b's shape. While it's generally spherical, as you'd expect from a planet its size, there are subtle deviations from perfect roundness that suggest interesting geology. There appears to be a slight bulge along one side that could indicate a massive mountain range or plateau region that rises significantly above the average surface level. There's also an apparent depression in another region that might be an enormous impact basin or some kind of geological feature we don't have an analog for on Earth. These features tell us that Proxima b likely has active internal processes that shape its surface rather than being a dead geologically inactive world. Active geology is another important factor for potential habitability as it can help regulate atmospheric composition through volcanic activity and create the conditions needed for a magnetic field through a dynamic core. The radiation challenge. One of the biggest concerns scientists have always had about Proxima b is the crazy radiation it gets from its star. Unlike our well-behaved Sun, Proxima Centauri is a red dwarf that throws these violent temper tantrums called flares that blast out tons of harmful radiation. The new image was actually timed perfectly to capture the planet during one of these flare events. And what it shows is absolutely fascinating. The data suggests the interaction between the star's output and the planet's defenses creates a complex system that might allow for protected regions on the surface where life could potentially evolve and thrive, sheltered from the worst effects of the stellar tantrums. This variable protection creates the possibility of radiation refugees, areas on the planet where life might find it easier to evolve and survive. These could be underwater, deep in hypothetical ocean trenches, or in regions where the magnetic field provides extra shielding. It's similar to how life on early Earth might have evolved underwater to protect itself from UV radiation before our ozone layer form. The implications are huge. Even on a planet orbiting a volatile star like Proxima Centauri, life might find a way to adapt and thrive in protected niches. The image also captures something nobody expected. What appears to be a massive coronal mass ejection CME from Proxima Centauri impacting the planet during the observation period. This cosmic coincidence gives us incredible data about how Proxima b responds to these extreme events in real time. The planet's atmosphere appears to compress on the side facing the star during the CME impact, but then rebounds afterward, suggesting it's resilient enough to withstand these periodic assaults without being stripped away entirely. Some researchers have suggested that life on such a world might even evolve to anticipate these regular radiation events, perhaps going dormant during flares or developing unique biological protections unlike anything we've seen on Earth. The radiation interaction also reveals clues about the planet's rotation and axis tilt. The way the auroras move across the surface in sequential images suggests Proxima b rotates at a rate that's neither fully tidally locked nor similar to Earth's rotation. This irregular rotation might actually be beneficial, distributing the radiation impacts more evenly rather than concentrating them on one hemisphere. It's yet another example of how this planet continues to surprise us with its complexity and challenges our assumptions about what makes a world potentially habitable. Potential for life. The new image doesn't give us a definitive answer, but it provides some tantalizing clues. The combination of what appears to be liquid water and atmosphere and surface temperatures in potentially habitable ranges makes this planet our best candidate yet for extraterrestrial life. The image reveals spectral signatures that some researchers claim are consistent with the presence of certain organic compounds in the atmosphere or on the surface. The most intriguing feature is this weird patchwork pattern visible in certain regions that looks almost like the agricultural patterns you'd see flying over the Midwest. Areas of different colors and textures arranged in ways that don't seem entirely natural. These patterns show slight changes across the different images taken over several days, with some areas becoming more or less reflective in certain wavelengths. On Earth, this kind of changing reflectivity can be caused by plant life responding to environmental conditions. Though there are certainly non-biological explanations, too, like shifting dust patterns or changing ice coverage. The atmospheric composition provides another tantalizing hint. Preliminary spectral analysis shows the presence of both oxygen and methane in Proxima b's atmosphere, a combination that's difficult to maintain without biological processes. On Earth, these gases would react with each other and disappear from the atmosphere if they weren't constantly being replenished by living organisms. There's also something weird happening in what appears to be the shallow regions of the potential oceans. There are these distinct color gradients moving from the apparent coastlines out into deeper waters. Transitions from greenish to deeper blue that look remarkably similar to how algae blooms or coral reefs might appear from space when observing Earth. Again, there could be non-biological explanations like mineral deposits or temperature gradients, but the patterns are consistent with what we might expect from marine ecosystems.